connection head of the transducer does not have to be rated for the Class 1 Division 1 area if certain conditions are met. Firstly, the loop-powered 4 to 20 mA signal must be intrinsically safe, meaning it lacks the potential to ignite a flammable atmosphere. Achieving this involves techniques like limiting voltage and current to safe levels or employing a special isolator to confine the signal within the safe area. Secondly, the intrinsically safe barriers must be properly installed and maintained to guarantee continuous signal protection within the safe area. This necessitates utilizing barriers certified for the specific hazardous area classification and ensuring correct and secure wiring connections. Thirdly, the connection head must reside in a non-hazardous area, shielded from flammable atmospheres or potential ignition sources. By adhering to these guidelines, safe transducer installation in a Class 1 Division 1 area can be achieved without needing an area-rated connection head. Intrinsic safety is a protection technique for electrical equipment used in hazardous areas. A hazardous area is an area where flammable gases, vapors, or dust are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. The basic principle behind intrinsic safety is to limit the energy available in the electrical circuit to a level that is below the minimum ignition energy of the flammable material. This is achieved by limiting the voltage and current in the circuit. Intrinsically safe circuits are designed to be incapable of causing ignition even under fault conditions. This means that even if a wire breaks or a component fails, the circuit will not produce enough energy to ignite the flammable material. Intrinsically safe equipment is typically used in hazardous areas where there is a high risk of explosion. Examples of such areas include chemical plants, oil refineries, and mines. Intrinsically safe equipment must be certified by a recognized testing laboratory. The certification process ensures that the equipment meets the requirements of the relevant safety standards. When installing intrinsically safe equipment, it is important to follow the manufacturer's instructions carefully. This includes using the correct wiring and grounding techniques. It is also important to ensure that the equipment is properly maintained. Here are some of the benefits of using intrinsically safe equipment. Firstly, it reduces the risk of explosion in hazardous areas. Secondly, it protects workers from injury. Thirdly, it minimizes damage to property. Fourthly, it helps to maintain production. Fifthly, it complies with safety regulations. Loop-powered 4 to 20 mA signals are commonly used in industrial process control and instrumentation systems. They are used to transmit analog data, such as temperature, pressure, flow, and level from sensors to control systems. The 4 to 20 mA signal is a current signal, which means that the signal is represented by the amount of current flowing through the loop. The 4 mA value represents the zero or low end of the measurement range, while the 20 mA value represents the full or high end of the measurement range. The loop-powered aspect means that the power to operate the sensor and transmit the signal is supplied by the same two wires that carry the 4 to 20 mA signal. This simplifies wiring and reduces the cost of installation. The intrinsically safe barrier is a device that is used to limit the energy that can flow into a hazardous area. The barrier is placed in the safe area and it is connected to the intrinsically safe circuit in the hazardous area. The barrier limits the voltage and current that can flow into the hazardous area to a level that is below the minimum ignition energy of the flammable material. Intrinsically safe barriers are typically used in conjunction with intrinsically safe equipment. They are used to protect the intrinsically safe circuit from faults that may occur in the safe area. Class 1 Division 1 is a hazardous area classification that is defined by the National Electrical Code (NEC). A Class 1 location is a location where flammable gases or vapors or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. A Division 1 location is a location where a hazardous atmosphere is present continuously, intermittently, or periodically under normal operating conditions. In other words, a Class 1 Division 1 area is a location where there is a high risk of explosion. Connection heads are enclosures that are used to protect electrical connections from the environment. They are typically used in industrial applications where the connections may be exposed to moisture, dust, or other contaminants. Connection heads are available in a variety of materials, including metal, plastic, and fiberglass. The connection head of the transducer does not have to be rated for the Class 1 Division 1 area if the following conditions are met. Firstly, the loop-powered 4 to 20 mA signal is intrinsically safe. Secondly, the intrinsically safe barriers are properly installed and maintained. Thirdly, the connection head is located in a non-hazardous area. If these conditions are met, then the connection head does not need to be rated for the Class 1 Division 1 area because the intrinsically safe barrier will protect the circuit from any potential ignition sources. However, it is still important to ensure that the connection head is suitable for the environment in which it is being used. For example, if the connection head is being used in a wet environment, then it should be made of a waterproof material. Here are some additional things to keep in mind. Firstly, always consult with a qualified professional before installing any electrical equipment in a hazardous area. Secondly, always follow the manufacturer's instructions when installing and maintaining intrinsically safe equipment. Thirdly, always use certified intrinsically safe equipment. Fourthly, always inspect intrinsically safe equipment regularly for any signs of damage. Fifthly, always replace any damaged intrinsically safe equipment immediately. By following these guidelines, you can help to ensure the safety of yourself and others in hazardous areas. Limiting voltage and current to safe levels is crucial for intrinsic safety. This involves using components and circuit designs that inherently restrict the amount of electrical energy that can be released into the hazardous area. Zener diodes, resistors, and other current-limiting devices are commonly employed to achieve this. These components are carefully selected to ensure that even under fault conditions, the energy levels remain below the ignition threshold of the flammable substances present. Special isolators, also known as intrinsically safe barriers, play a vital role in preventing the signal from escaping the safe area. These devices are designed to galvanically isolate the intrinsically safe circuit from the non-intrinsically safe circuit. This means that there is no direct electrical connection between the two circuits, which prevents any fault currents from flowing from the non-intrinsically safe area into the hazardous area. The isolators typically use transformers or optocouplers to provide the isolation. Proper installation and maintenance of intrinsically safe barriers are essential for ensuring their effectiveness. This includes verifying that the barriers are certified for the specific hazardous area classification and that they are installed in accordance with the manufacturer's instructions. Regular inspections and testing should be conducted to identify any signs of damage or malfunction. Wiring connections must be properly made and secured to prevent any accidental disconnections or short circuits. Ensuring that the connection head is located in a non-hazardous area is a simple but effective way to minimize the risk of ignition. This involves placing the connection head outside of the Class 1 Division 1 area, where it is not exposed to flammable atmospheres or other potential ignition sources. The non-hazardous area should be clearly defined and separated from the hazardous area. Consider a scenario where a temperature transmitter is installed in a Class 1 Division 1 area to monitor the temperature of a chemical reactor. The transmitter is loop-powered with a 4 to 20 mA signal and is connected to a control system located in a safe area. An intrinsically safe barrier is used to isolate the intrinsically safe circuit in the hazardous area from the non-intrinsically safe circuit in the safe area. The connection head of the transmitter is located in the Class 1 Division 1 area, but it is not rated for the hazardous area. This is because the loop-powered 4 to 20 mA signal is intrinsically safe, the intrinsically safe barrier is properly installed and maintained, and the connection head is not exposed to any flammable atmospheres or other potential ignition sources. In this scenario, the temperature transmitter can be safely installed in the Class 1 Division 1 area without the need for an area-rated connection head. However, it is important to note that this is just one example, and the specific requirements for each application may vary. It is always recommended to consult with a qualified professional to determine the appropriate safety measures for each situation. In summary, the connection head of a transducer in a loop-powered 4 to 20 mA intrinsically safe system within a Class 1 Division 1 area does not necessarily require area rating, provided that the system adheres to intrinsic safety principles, utilizes appropriately certified and maintained barriers, and ensures the connection head resides outside the hazardous zone. The loop-powered 4 to 20 mA signal is a common standard in process instrumentation for transmitting analog data over long distances. The current signal is less susceptible to noise and voltage drops compared to voltage signals, making it ideal for industrial environments. The 4 mA 0 point allows for detecting broken wires or open circuits, as a current below 4 mA indicates a fault condition. The intrinsically safe barrier limits the voltage, current, and energy that can enter the hazardous area, preventing ignition of flammable substances. It typically includes components like resistors, diodes, and fuses to limit energy levels and ensure safety. The barrier's certification ensures it has been tested and approved for use in specific hazardous environments, complying with relevant safety standards like Underwriters Laboratories, UL, or European norms, N. The wiring must adhere to specific guidelines, including using twisted pair cables, shielded cables, and proper grounding techniques to minimize interference and ensure the integrity of the intrinsically safe circuit. The connection head, while not area-rated in this specific scenario, should still provide adequate environmental protection, such as resistance to moisture, dust, and corrosion, to ensure reliable operation. The overall safety of the system depends on the proper design, installation, and maintenance of all components, including the sensor, wiring, barriers, and control system. Regular inspections and testing are crucial to identify any potential issues and ensure continued safe operation. It's important to consult with qualified professionals experienced in hazardous area installations to ensure compliance with all applicable regulations and standards. The NEC, National Electrical Code, provides detailed guidelines for electrical installations in hazardous locations, including requirements for intrinsically safe systems. Understanding the specific requirements for the Class 1 Division 1 area and the characteristics of the flammable substances present is essential for selecting the appropriate equipment and installation methods. Training and education for personnel involved in the installation, maintenance, and operation of intrinsically safe systems are crucial to ensure they understand the principles of intrinsic safety and the proper procedures for working in hazardous areas. The use of appropriate personal protective equipment, PPE, such as safety glasses, gloves, and grounding straps, is also essential when working in hazardous areas. Documentation, including drawings, wiring diagrams, and maintenance records, should be maintained for all intrinsically safe systems to facilitate troubleshooting and ensure compliance with safety regulations. Periodic audits and inspections should be conducted to verify the effectiveness of the intrinsically safe system and identify any areas for improvement. The intrinsically safe approach is a proven and reliable method for preventing explosions in hazardous areas, but it requires careful attention to detail and adherence to strict safety standards. It's important to stay informed about the latest advancements in intrinsically safe technology and best practices to ensure the continued safety of personnel and equipment. The information provided here is for general guidance only and should not be considered a substitute for professional engineering advice. Always consult with qualified professionals to determine the appropriate safety measures for your specific application. The design and implementation of intrinsically safe systems can be complex, requiring specialized knowledge and expertise. It's important to work with experienced professionals who can provide guidance and support throughout the entire process. The selection of appropriate intrinsically safe equipment is crucial for ensuring the safety of the system. The equipment must be certified for the specific hazardous area classification and must be compatible with the other components in the system. The installation of intrinsically safe equipment must be performed by qualified personnel who are familiar with the applicable safety standards. The wiring must be properly installed and terminated to ensure that the intrinsically safe circuit is protected from faults. Regular maintenance and inspection of intrinsically safe equipment are essential for ensuring its continued safe operation. Any damaged or malfunctioning equipment must be replaced immediately. The use of intrinsically safe systems is not a guarantee of safety, but it significantly reduces the risk of explosion in hazardous areas. The overall safety of the system depends on the proper design, installation, maintenance, and operation of all components. It's important to follow all applicable safety regulations and standards and to consult with qualified professionals for guidance and support.